so far we've talked about two types of limicons. We've talked about the inner loop, that's where B is bigger than A, and then we have talked about cardioids, and that's where A and B are equal to each other. So the last type we have are these dimpled limicons, and this is when A is going to be bigger than B. You're still going to tell, so this one would be to the left of the pole, so this means we would be working with the negative cosine, right of the pole, so positive cosine, above the pole, so positive sign, below the pole, so negative sign. So those rules are still going to apply. To figure out how far it's going to go, you're still going to add A plus B. This time, because A is bigger, you're going to do A minus B, and that tells you how far you're going to put your dimple. A is still going to be used to get your other measurement that we're going to have here. Okay, so, and remember these also do take 2 pi radians to trace because we're going to use all 4 quadrants. So if we look at our first examples here, we have 5 minus 3 cosine theta. So here our A is 5 and our B is 3. So because our A is bigger, we're going to have a dimpled limicon. Okay, so because this is negative cosine, this is going to go to the left of the pole. So to figure out where we're going to graph, we're going to do A plus B first. So if we do 5 plus 3, we're going to get 8. So we are not going to have a point at the pole this time, okay? So the other two you do, but there's no point at the pole. So just pretend like you're at the pole. We are going to go left 8 spaces, so one of our points is going to be here. To figure out where your dimple is going to go, you're going to do A minus B. So 5 minus 3 is going to give you 2. Your dimple is going to go the opposite way of your main point. So you're going to go 2 spaces to the right this time. And then to figure out how far up and how far down you're going to go, you're always using that A value, which in this case is 5. So when you're drawing this, you're going to have your circular shape here. And then it looks like a cardioid, except for it's not going to dimple into the pole. It's going to dimple into your extra point that you have there. And this should have been a little more over. But so it's going to look something like that. So that's called a dimpled limicon. So looking at the one to the right, in this one, A is 4 and B is 3. So because A is bigger, we have a dimpled limicon. Because this is positive sign, we're going to be above the pole. So to figure out where we're going to put our dots, we're going to do A plus B, which will be 4 plus 3 or 7. So you're not going to have a point at the pole, but you're going to go up 7 spaces and you're going to have a point. To figure out where your dimple is going to go, you're going to do A minus B, which is going to be 1. So you're going to go backwards 1 space for your dimple. And then to figure out right and left, you're going to use that A value. So you're going to go right and left 4 spaces. So when you draw in your circular part here, and then this will dimple in to that part there. Alright, so next here we have A is 4. There's not a number with sign, so that means B is 1. Because A is bigger, that means we have a dimpled limicon. Because we have negative sign, that means we're going to be below the pole. So to figure out where our points are going to go, if we do A plus B, we're going to have 4 plus 1, which is 5. So no point at the pole, but we're going to go down 5 spaces. To figure out where our dimple is going to go, we're going to do A minus B, which will be 3. So we're going to go backwards 3 spaces, so up 3 spaces. To the left and right is going to be our A value, which is 4. So then we can draw in this. So if you notice, this one is getting closer to being like a circular shape because it's almost equal there. So sometimes these aren't the easiest to draw. Just make sure if you were drawing this with something, you have your points exactly where you can tell where they are. And then the last one we have, here we have our A is 3 and our B is 2. So because A is bigger, we have a dimpled limicon. This is positive cosine, so we're going to be to the right of the pole. get our measurements, A plus B is going to be 5. So we do not have a point at the pole, but we're going to go 5 spaces to the right. To figure out where our dimple is going to be, we're going to do A minus B, which is 1. So we're going to go backwards 1 space, or to the left 1 space. To figure out up and down, you're going to do your A value, which is 3. And then you can draw in your dimpled limicon. So, 3 types of limicons. Inner loop is when B is bigger. Cardioid is when A and B are the same number. Dimpled limicons is when A is bigger. Okay. So next, we are talking about lemniscates. The good thing about these is there's only one certain formula. It has to look exactly like the formula in order for it to work. So it's going to be r squared equals a squared cosine 2 theta, or r squared equals a squared sine 2 theta. So for a lemniscate, it has to have 2 with a theta here. Okay, it does look like your flower curve, your rose curve, which is like a flower. But remember, for a rose curve, it was just r equals. And remember, if it would have been 2, we would have had to double it because it's even. We'd have to have 4 petals, well, we only have 2 petals here. So this is how a lemniscate is going to look. There is another way that we could write these, and I'll look at that when we get to our examples. But for right now, r squared, okay, it should be some number a squared cosine 2 theta or sine 2 theta. So if it is cosine, remember cosine goes with x. Cosine means that it's going to be on this polar axis. So it's going to be at 0 and it's going to be at pi for your petals, okay? And that's exactly where your petals are going to go. The length of each petal is going to be your a value, so you would have to square root this number to get that. Sine goes with y. So sine is going to always have this shape here. It will always be at pi over 4, which is the middle line on your unit circle here, and then at 5 pi over 4. So that's where your petals are going to go. So there's really only 2 options for how this is going to look for your lemniscates. And so let's look at these examples. Okay, so looking at this first one, we have r squared equals 16 cosine 2 theta. So this 2 right here and this r squared should be your clue that this is a lemniscate. Okay, a couple of other things we need to look at. Because this 16 is really your a squared value, that means your a is 4. So squared is 16. This tells you the length of your petals. For a lemniscate, you're going to have 2 petals always. Because it is cosine, that means that your petals are going to be at 0 and at pi. So they're going to be along that x-axis, okay? So we're going to put a dot at our pole. We're going to have a length of 4, so we're going to go 4 to the right. And we're going to draw in our petal. And then we're going to go 4 to the left, which is at pi. And we're going to draw in our petal. So that's how your lemniscate should look for that. Okay? Alright, other example, or last example for lemniscate. This one looks a little different. It's r equals the square root of 36 to 2 theta. So think about if I was to square both sides. This is the same thing as r squared equals 36 sine of 2 theta. So this is another way you might see a lemniscate written. But just think about if you were to square it, it would look like that. So, things about this. This is 36, so that's your a squared value. So that means your a value is 6. Okay, that tells you the length of your petals. And then because we're working with sine here, that means your petals are going to be at pi over 4 and 5 pi over 4. So we're going to have a dot in the middle. Now, if you notice this polar graph that I'm giving you here doesn't have that middle line there, okay, perfectly fine. So just think about this is where pi over 4 would be. This is where 5 pi over 4 would be. We're going to move up 6 spaces. 1, 2. So here is going to be 1 petal. And then we're going to move this way 6 spaces. And so there's that. So those are lemniscates. So it's like a rose curve, but only has 2 petals. Okay, the last thing that we're going to do is I just have a bunch of polar equations, and we want to just figure out which one, and I have it over here, is going to be, or which is each type, okay? So we have all the limicons, cardioid, we have rose curves, we have circle. So if you look at the first one, see we have this number and number here, so it can be a circle or a rose curve. So this is your A value and this is your B value. So because A is bigger, remember when A is bigger, that's when we have the dimpled limicon. Alright, 2 is 4 cosine 2 theta. So it doesn't have that number out front, so it can't be a limicon. And because it has this number on the inside, but it is a 2, which is fine, but because it's not squared, it's not going to be a lemniscate, it's just going to be a rose curve. Alright, now 3 has the r squared, so it has r squared, and it has that 2 in there. So because it has those two things, this is going to be a lemniscate. Alright, 4 just says r equals 10. Remember, r equals 10 just means radius equals 10, so that means that has to be a circle. Alright, for number 5, we have 3 plus 3 sine theta. So we have the same A and B. So when you have the same A and B, that means it's a cardioid. For number 6, is r equals the square root. Well, remember, we could write that as r equals, or that is r squared equals 4 cosine 2 theta. So because it has the r squared and it has the 2, that has to be a lemniscate. Number 7 is 6 sine theta. So no number in the inside here, just the number on the outside. So this is just a circle. And then for number 8, we have 5 sine 4 theta. So because we have that 4 on the inside, this is a rose curve. And then for the last one, number 9, you can leave it like this, or if you want to distribute that 5, it would be 5 plus 5 cosine theta. So because these have the same A and B value, we know that has to be a cardioid. Alright, so just by looking at the polar equations, you should be able to tell what type of graph, polar graph, that you're going to have there.